Hi everyone. Today we are going to learn about lightning. Lightning is something that's pretty fascinating to a lot of us. So it's an interesting topic. There's a nice little picture of lightning here for you. Okay, so we'll just take care. Oh, sorry, I just gotta grab my binder. Just a minute. Okay. Lightning transfers electrons from the atmosphere to the earth. So remember, electricity is just electrons. It's a stream of electrons. So electrons build up in clouds because wind causes them to rub together. So this is charging by friction. And then after that, the negative charges in the clouds push the negative charges in the ground away, leaving the positive charges on the surface. Charging by induction, where I just skip that stuff out just during this time here. We're not going to worry about that part. And then once enough negative charges build up in a cloud, it repels so strongly, I'll cross those out, that it jumps through the air. So the air is an insulator and it strikes the positively charged ground or the nearest object, the highest object. And that's we're going to talk more about that in a minute here. This is just a diagram or a picture of a pretty intense lightning bolt. So as you can see it, that's where it struck the ground and where it's been released. So this is a neat animation here. So what ends up happening, it'll repeat here. So we get these negative electrons up here collecting up top and they go near the bottom. Now, what you'll see in the ground, notice how it starts out with electrons, and then when the electrons start collecting here, the electrons on the earth start going away. They don't want to be near it. Remember, charges that are the same, like charges, repel each other. So when these ones go away at the bottom, we get left with a positively charged earth here. So what ends up happening is the electrons that are all collecting up here, they are attracted to these positives here, and they're going to come down. So the electrons come down, and then once they hit the earth, we get what's called a discharge of electricity. So we get a discharge, and that's when you're going to see your lightning bolt strike up. Okay, so you need to draw yourself some sort of little diagram there of how that works. I'll just erase my markings here so you can see it. So draw yourself a diagram in that box there. Okay, now, so lightning comes from the ground up, or it can move from cloud to cloud. So we tend to think of lightning bolts coming down from the sky, but that's not actually true. The lightning is going to come from the ground and move up, so it gets discharged or grounded, and then you have the discharge of electricity, so it comes up. So this is just a diagram here. You can also see lightning in the sky, so it can go from cloud to cloud. And so as you can see here, the negatives here are attracted to the positives here. So they are going to travel to the positives. And once they touch the positives here, that's when you get the discharge of electricity. And that's when you would see the lightning bolts. Now, every time you get a shock, that's actually a mini bolt of lightning. If you've ever put a sweater on, this usually happens in winter when the air is dry, and if you put on a sweater and there's static in it, sometimes if it's dark, and try this maybe, if it's really dark, you'll actually see the sparks, and those are actually just mini bolts of lightning. So anytime, say you got a charge or a shock from a door handle, for example, or say you move across the carpet, shuffling your feet, and you're building up charges, and then I don't know if you ever had like a shock fight with someone where you rub your feet on the carpet and you build up charge in your body, and then when you touch them, it discharges and gives them a shock. Those are actually just mini bolts of lightning. So those are the same things. It's just a releasing of the electricity or releasing of the electrons. Okay, so that says lightning rods there. So we're just going to talk about lightning rods, and then I'll get you to sketch this. So basically how this works, again, we've got the negative charges in the cloud, right? So these are happening because the clouds are rubbing together and you're getting a buildup of electrons. So they're stripping electrons off part of the cloud and putting them on another. We talked about charging by friction in our last lesson here. Now, the positive ions here, oh, sorry. Okay, so we've got our negatives right there, the base of the cloud. Now, a lightning rod. So some of you will have heard this term before. Even in downtown Winnipeg, some of our tall buildings have lightning rods on them. What they are when you would put something that's going to sit at the highest point. Now, electrons always want to take the easiest path. So they are going to be attracted to the spot that's the highest point. And that's why you would never stand under a tree in a lightning storm, because that tree is a high point. And so the electrons are looking for things. They're going to be attracted to the positive earth, and the highest points that there are where they're going to be attracted to. So we've got this lightning rod on top of this house. So this would be like in a farmland in the country where this house is a high point. So the house has to be careful. The house does not, or people who own the house, I guess, do not want that house to be hit by lightning. So you have what's called a lightning rod. So this is going to be made out of a conductor because you want the electricity to be able to travel. So you've got a conductor, so some sort of metal rod, and it's going to be sitting again at the highest point. So when the electrons here are looking to be discharged, they're going to be attracted to this, and this is going to have an overall positive charge because, again, the electrons are wanting to get away from that negative cloud. So when the lightning bolt comes down, oh, I should have done a different color. Yeah, let's do yellow. Oh, I said it comes down. The lightning bolt doesn't come down. The electrons come down. It's going to touch the rod, and then it is going to travel in the rod and down, because this would be very, very hot, and people have, I'll post some videos of how lightning just burns things. It's extremely hot. It's going to travel down the rod, and this rod is going to be, usually it can be buried deep in the ground. So it would be somewhere in the ground here, and then those charges would be dispersed safely. So it's not going to, so it won't be able to burn anything because it's going into the earth. And the earth is a huge reservoir of positives and negatives. So we can ground, it's called grounding things on the earth. And then it's safe. Okay, so you want to have a diagram here. So you're just going to sketch a house with a rod sticking up out of it, draw your negative cloud up here, and then the negatives coming down, being attracted to that rod and being deposited through the rod deep in the earth, okay? So that's what I want you to draw there. Okay, now your assignment for this one is page 224, questions 2 to 6. It's kind of an interesting little case study about someone who's out in a lightning storm, and this is going to be for hand-in, and I'll let you know more about that later. Okay, thanks guys.